Okay, college algebra, we're going to pick back up in lesson 4.2. We're going to look at our application problems today. We're going to look at compound interest, and we'll start off with this formula. It should be kind of familiar to you. All right, with this formula, your book calls P the present value. So, for example, that might be the amount of money you're investing, the amount of money you're borrowing, but it's considered present value in this textbook. The R is your interest rate. It will be given to you as a percent, and that percent needs to be written as a decimal. N is going to be the number of times the interest is compounded. For example, if the interest is compounded monthly, then N would be 12. Quarterly, N would be 4. Let's see, semi-annually would be an N of 2. T is going to be the number of years. All right. Suppose $2,500 is deposited in an account paying 6% per year compounded semi-annually. So we see semi-annually, that's going to indicate that your N is 2. The 6% is 0.06. That's your interest rate. The $2,500, that's the P, that's the present value. And we want to find the amount in the account after 10 years. So that is going to be our A. A equals P times 1 plus R over N to the NT. All right. I expect you guys to be able to put that right into your calculator. And let's see, bear with me a second. I need to find my calculator. Oh, goodness. Oh, here it is. Sorry, my desk area is a little bit unorganized. Okay, here we go. 2,500 times 1 plus 0.06 divided by 2 caret 20. So you're going to type it in just like you see it. You should get an answer of about $4,515.29. 28 cents. Let me look at that, make sure I've got it in there correctly. Okay, if you don't get that answer, you need to try again with your calculator. It could be that you don't have enough parentheses right here and so forth. But what I'd like for you guys to do is to be able to type that straight into your calculator without taking extra steps. Okay, we want to know the interest that was earned over 10 years. So we're going to take the amount after time, and we're going to subtract the amount that we deposited. And that's going to give us the amount of interest. All right, moving on. Brendan must pay a lump sum of $15,000 in 8 years. So this is going to be considered the amount after time. 8 is your time. What amount deposited today? So you're finding P at 4.8% compounded annually. Annually is going to be an N of 1. Is going to yield that $15,000 in 8 years. Again, this is your formula. So we're going to be putting 15,000 right here. We're finding P. Our interest rate was 4.8. N was 1. And 8 years. Okay. We want to get this P by itself. In order to do that, we're going to take 15,000 and divide by this quantity. And again, you should be able to put that straight into your calculator. Now you might have to take and stick in an extra set of parentheses there. Okay, I have P is approximately $10,308.63. All right, now the next question says only $10,000 is available. What annual interest rate, so we're going to find R, is necessary for the money to increase to $15,000? So we're still trying to get to that $15,000, but we don't have quite this amount of money. We only have $10,000 available. So that means we're going to have a different interest rate in order for that to happen. So 15,000 is what we want to end up with. We start with 10,000 instead. We don't know the interest rate. We know it's compounded annually. And we know that we want to leave it in there for 8 years. So 8 times 1. Okay, let's just clean this up a little bit. Okay, we're going to try to get this R here by itself. So the goal is to get this piece by itself first. So we're going to divide by 1,000 on both, or 10,000 on both sides. So 1.5. Okay, I'm going to go backwards a little bit. In our previous lesson, we had fractional exponents right here, and the way that we got rid of them was to actually go through and multiply by the reciprocal. So that's what we're going to apply here. We're going to multiply or raise it to the 1/8 power. So 1.5 to the 1/8 equals 1 plus R. Before I put it in my calculator, I'm going to subtract the 1 over. So now I'm going to put that into my calculator. 1.5 to the 1 divided by 8. Then I'm going to subtract 1. And that gives me an interest rate of 0.0519, etc. All right. I'm going to, oops, I did not write that correctly. Let's try that again. Okay, you're going to want to round that to 3 decimal places so that you can write it as a percent to 1 decimal place. So to go to a percent, you just multiply it by 100. There you go. All right, now we move on to situations where the interest is compounded continuously. And for that, you get a new formula, but it's a little bit shorter. E is the decimal value 2.72 ... It is found just above the natural log key on your calculator. There's probably a key there that says e to the x. So if you type in e to the first, you're going to get about 2.72. Okay. We're going to deposit $8,000, so that is your present value, that is your P. The account pays 5%, that's your interest rate. Compounded continuously for 6 years. Find the total amount on deposit, so we're finding A after our 6 years is over. And once we put that in our calculator, round that to 2 decimal places, $10,798.87. Again, I put all of that into my calculator without any extra steps. All right, you will have exponential models in your homework as well. And so for these, y of 0 is always going to be the beginning amount. T for these can be any unit of time. So it's not going to always be years. It might be minutes, seconds. It doesn't matter. T is just a unit of time. K is your exponential growth or decay constant. Okay, they're talking a lot about the COVID-19 virus growing exponentially. So it's following this kind of a model. Okay, in our problem on page 434, it's number 108. It says the world population in millions closely fits this exponential function, where x is the number of years since 2000. Part A, the world population was about 6,853 million in 2010. How closely does the function approximate this value? All right, so 6853 is going to be our y. Okay. Oh, I am sorry, I'm leading you down the wrong path. Let me start over. It says that the population was 6853 in 2010. So we want to use the model to see how close we can get to that number. So what we're going to do is we're going to find a y value. And we're going to plug in 10 for our time. So we want to know how true this model is 10 years down the road. So we're going to put that into our calculator. And we get about 6860 million people. Now it says that the actual population was 6853. So this is about 7 million higher than the actual population. So you're comparing what the model says to what was really true in 2010. Part B, use the model to predict the population in 2020 and 2030. So for 2020, X is the number of years since 2000. Our X is going to be 20. And so we're just going to do the same problem, except we're going to plug in 20 for our time. And then for 2030, we're going to be plugging in 30. And you would just finish those off by rounding, putting them in your calculator and rounding them to the nearest whole number, and then tying the word million to the end. Oh, my dogs just came over to say hi to me. They just interrupted my lesson. Hi, guys. Okay, so for this first one, I got 7,734 million. And when I plug in 30, $8,720.4. Whoops, I told you guys to round. There we go. Now, if you've watched this video, I'm going to throw in a few extra credit problems. I want you guys to do a little Google search, and I want you to see how close the world population is right now. So Google world population for 2020, and I want you to compare that result to what we found here in this word problem. How close does the internet say our population is? Is it close to 7,734 million? And I want you to also share with me the website that you found this information on. So that's the first extra credit task. And the second one is I want you guys to do a little research on the internet, see if you can find the exponential function for the COVID-19 virus. And I would also like to know your source for that one. So you've got two opportunities for bonus on here. Let's see what you can do. Thank you.